How does my game combine discrete and continuous movement? What are the differences between the two? And why do games use one type of movement over the other? You will learn all of this in this video, but first let's establish basic definitions. Discrete movement means that possible positions at which an entity can be placed are well defined and usually take the form of fields or grid. So let's look at the example from my game. Pumpkins can be placed here, here or here, but not half at one field and second at the other. Positions are represented by two integer numbers corresponding to x and y coordinates. Continuous movement simply means that entity positions are not restricted to concrete fields. So pumpkins could be placed anywhere between two fields, as x and y coordinates are real numbers. Well, to be completely true, there is no such thing as fully continuous movement, simply because computers represent numbers as ones and zeros. That fact alone limits the number of possible values that entity position can have, but for our purposes, floating point numbers on computers are as good as real ones. Examples of discrete games are Heroes of Might and Magic, Dwarf Fortress, or even chess. Games with continuous movement are, for example, Diablo, Witcher 3 or Doom. This gives us a good overall look at which types of games discrete movement is best suited. These are games in which your effectiveness comes almost completely from how smart, clever or good memory you have. These are often turn-based games or games with active pause. On the other hand, continuous movement is more often found in games that test players' dexterity. Yet, as it often happens, no one-size-fits-all solution for movement exists, so often games use a combination of both approaches. If you look at the game like Crypt of the Necrodancer, it uses grid-based movement, so the set of possible positions is finite, yet this is still a dexterity-based game. In the case of such a game, discrete-based movement is used to make the design cleaner and better indicate developers' intentions. It's easier for players to read distances between objects in terms of how many times I need to press this button, etc. Another topic is that, even though it is a game with grid-based movement, characters are smoothly transferring from place to place, which makes it feel more pleasant to look and easier to follow. I use the same approach in Pumpkin Man. Discrete movement allows players to better read distances so they don't accidentally kill themselves or walk into enemies. Same as in Crypt of the Necrodancer, characters don't just teleport between fields. Instead, it's smoothly moved. It's quite interesting how something like this works, so let's go deeper into this topic. This is what the first version of my movement system looked like at the beginning of the development. It was the quickest way to do that and to implement some basic logic, like destroying walls. Entity's position was represented by just two integer numbers. When at one point I wanted to add smooth transferring, at first I didn't want to throw away all the movement code I already had, so I added a speed parameter to moving characters which represents how many fields it traverses in 1 second. Then, when movement was started, I started a timer which held information about how much time the character has already been moving. When the timer counted past half the time required to complete a single move, I changed the position of the character in the game logic. The sprite position on the screen was interpolated from those time measurements for the player to see. This approach did work, but it had many drawbacks. Most notably, every time I needed an exact character position on the screen, for example, to generate particles or to make the camera follow a character, I had to go through calculations, which included checking how much time the character was moving, at which direction it was moving, etc. At some point, I did a complete makeover of my movement system to what I think is the correct solution. Now, each entity's position is represented by real numbers. This makes obtaining entity position on the screen trivial. I can simply use position value directly, no additional calculations needed. What's more important, converting from a real position to a field position is also trivial, and no external parameters are needed. I can just truncate the fractional part of the number. This way, all game logic is still discrete. For example, collision is only detected when two entities occupy the same field. But the underlying discrete logic is in some measure driven by the continuous parameters, which are way easier to work with. In the previous approach, a continuous parameter was also used, the movement time. But it was hidden, didn't relate directly to what was happening on the screen, and was weird to work with overall. That's all for today's video, hope you find it interesting. Subscribe for more and leave a comment if you have any questions. See you in 2 weeks and have a nice day.